Hello everyone, this is Ashna Jain from Acropolis Institute of Technology and Research, Indore, and this time our topic is computer graphics, pixels, frame buffer, and dead pixels. So let's get started. So first, what is computer graphics? So it is a field of computer science that deals with creating, manipulating and displaying visual content on computer screen. So whatever type of images or text or videos we can see on computer screen or display devices that can be possible due to computer graphics. So production of images on computer for use in any medium, for example, medium here is the visual medium where we can see different text, videos and elements on our display devices. So any type of images which can be seen on computers are made by graphic techniques by activating pixels of the screen. So first, let's discuss what are the use cases of computer graphics. So different colors and different animations that we can see on electronic games are possible due to computer graphics. Scientific visualization, window-based graphical user interface, and medical imaging are all the use cases of computer graphics. Next is the type of computer graphics. So there are mainly two types of computer graphic, that is raster graphic and vector graphics. In raster graphics, pixels are used to draw an image on the screen, and it is also known as bitmap images. So bitmap is basically the sequence of images which are divided into smaller pixels. So large number of pixels when came together, it is known as bitmap. And vector graphics, so in vector graphics we use mathematical functions and formulas to draw different types of shapes, lines and objects. Next is pixel. So pixel stands for picture element. It is the fundamental unit for displaying any type of images, videos, text on the computer screen. So it is the fundamental or smallest unit which can be changed to display any image. So to view a complete image, pixels are combined and they form a complete image, video and text that can be visible on a display device. Depending on graphic card and display monitor, the size and the quantity and the color combination. Color combination is like pixels can be available in three colors like red, blue and green, RGB channel, that what we say. So these color, size and quantity depends on the graphic card and the display monitor of the display devices, and it is measured in terms of display resolution. So for example, a display resolution of 1280 into 768 1280 into 768 will produce a maximum this much pixels on display screen. Further in pixels, we can say what do pixels look like. So pixels which are available in red, blue and green channels are look like this, a small unit. The specific color information that pixel describe is the blend of three components that we already discussed. It is RGB. So 3 bytes of data are allocated to specify a pixel color, and the physical size of pixel depend on set of resolution for display screen. So what is resolution? Resolution indicates the number of pixel per centimeter or per inch for an image. So pixels per centimeter is resolution. So the physical size of pixel depends on the resolution of display screen. There are also some criteria where pixel size differs. So the physical size of pixel will be equal to the dot size of the display. But if resolution is set to something less than the maximum resolution, then the pixel will be larger than the physical size of screen's dot. Next is dead pixel. So pixel is generally used to change colors, but dead pixel is a pixel which fails to change color. Dead pixels are distinguished from other pixels by remaining black at all times because it doesn't change any color. Regardless of image being displayed, a dead pixel will remain black. But what causes dead pixels? So failed means pixels require power to define their intensity and to bring out colors on the screen. So in most cases, dead pixels are a result of failed power or failed power connection. Because pixel require power to change color. If the power connection to the pixel is cut off, then it will become black. And the most fundamental cause of dead pixels are the manufacturing defect. Next is the frame buffer and memory buffer. So frame buffer is an area of memory which is used to store information related to pixel. Generally, intensity value of pixels are stored in the frame buffer. So at the time of scanning of any image, these intensity are read by the computers and display on the screen to show images, text and videos to the user. So it typically color display will have a frame buffer with up to 24 planes, 8 each for defining red, green and blue. Next, why do we need frame buffer? So as I already said that frame buffer is used to store the intensity value of pixel on the screen. So whenever picture is displayed on the screen, it has to be visible for some time only. Pictures are visible on the screen when certain pixels are eliminated by bombarding electrons on the phosphorus screen, but it only be visible till phosphorus comes to its normal state, from excited state to normal state. So to remain it for a longer period of time, to see it for a longer period of time, we use frame buffer where intensity values are stored, and then after scanning we can see the exact image there. So during raster scan, the scanning is done row to row, and the header read the intensity value and display the screen results on the screen. Then frame buffer architecture. So frame buffer is characterized by size XY and pixel depth, and resolution of frame buffer is the number of pixel in the display. For example, 1024 into 1024 pixels. Bit planes and bit depth are some of the concepts which are used in this architecture, which are the number of bits corresponding to each pixel. And this bit planes and bit depth determines the color resolution of the buffer. So how to specify color in a frame buffer? There are two methods: direct color specification and palette based color specification. So in direct color specification, each pixel directly specify a color value. In palette based color specification, we use palette which is a specifier color. This is somewhat a architecture where 24-bit planes are there, 8 bits per color gun for red, green and blue. So we have this much of color specification. Now, how images are displayed on screen using computer graphics. So first, this is the phenomena which we use in cathode ray tube architecture, where electron from this electron emitter are emitted and bombarded on the phosphorus screen. This is a phosphorus screen, and exciting the electrons of phosphorus, thus eliminating the pixels. These pixels are stored in the frame buffer, and then the color are specified using those two methods, palette method and direct method. And then the scanning is to be done. This is a raster scan method which scan all the pixel values and display the images as per the intensity value stored in the frame buffer. Thank you so much.